Welcome to the first module on the history and evolution of artificial intelligence. Today, we will walk through the major milestones that have shaped AI into what it is today. AI didn't just appear overnight. It has been developing for decades, starting with foundational concepts in the early 20th century. Many of the technologies we see today, from self-driving cars to personal assistants like Siri and Alexa, are the culmination of years of research and development. But where did it all begin? We begin with Alan Turing, a pivotal figure in the birth of AI. In 1950, he proposed what's now called the Turing test. This test was designed to determine whether a machine could exhibit intelligent behavior equivalent to, or indistinguishable from, that of a human. The idea was simple but profound. If a human couldn't tell the difference between another human and a machine in a conversation, that machine could be considered intelligent. This was the first major theoretical step in AI, setting the stage for further developments. Turing's work also laid the foundation for the development of logic machines, early devices that could process information through binary operations. During the 1950s and 1960s, AI researchers focused on what we call symbolic AI. This approach was based on machines that could perform tasks by manipulating symbols, like solving logical problems or performing algebraic computations. Researchers at the time believed that if they could build machines with enough rules and knowledge, they could create intelligent systems capable of handling almost any situation. However, while symbolic AI worked well for solving narrow, structured problems, it struggled with real-world complexity. There was a growing realization that the world wasn't just a series of fixed rules, but a dynamic and changing environment. In 1956, the Dartmouth Conference marked the official birth of AI as a field of study. This conference brought together top minds in computer science and mathematics and introduced the term artificial intelligence. There was a great deal of optimism at this time. Researchers believed that, within a few decades, machines would match or even surpass human intelligence. However, as we'll see, things were more challenging than expected. By the 1970s, the field had shifted towards the development of expert systems, which were programs designed to mimic human decision-making in specialized fields. Two famous examples are Dendrol, an expert system used in chemistry, and Mycin, which was developed for medical diagnosis. These systems were rule-based and aimed to replicate the decision-making process of human experts in specific domains. They achieved early success, but they had significant limitations. These systems worked well within their narrow fields but struggled when confronted with broader, more nuanced problems. Expert systems didn't generalize well outside their initial scope. This, combined with overly ambitious expectations, led to what is known as the AI winter. The AI winter refers to a period during the 1980s and early 1990s when both funding and interest in AI research declined dramatically. The field had overpromised and underdelivered, leading to disillusionment. Governments and companies that had invested heavily in AI pulled back, and the field stagnated. However, during this time, crucial advancements were still being made behind the scenes. As computing power improved in the 1990s, AI researchers began to move away from symbolic systems and rule-based programming and towards machine learning. Instead of manually coding rules into a system, machine learning allowed computers to learn from data. This was a massive shift in how AI was approached. Instead of predefining every possible scenario, the machine could generalize from examples and make decisions in new situations. One of the most critical developments during this time was the rise of neural networks. A neural network is a computational model inspired by the structure of the human brain, with interconnected nodes or neurons that process data. Early neural networks were limited in scope, but the introduction of backpropagation in 1986 marked a turning point. Backpropagation allowed neural networks to adjust their internal parameters through training, making them much more effective at learning from data. But it wasn't until the 2000s that neural networks truly began to dominate. The advent of deep learning, a subset of machine learning that uses neural networks with many layers or depth, transformed AI once again. Deep learning models, with their multiple layers of neurons, were able to understand and process incredibly complex data patterns. This breakthrough led to some of the most notable achievements in AI, such as Deep Blue's victory over world chess champion Garry Kasparov in 1997 and, more recently, AlphaGo's success in mastering the game of Go, a much more complex and strategic game than chess. AI's impact has moved far beyond gaming. In healthcare, AI is revolutionizing diagnostics by analyzing medical images, predicting disease outbreaks, and even helping to personalize treatments for patients based on their genetic makeup. In autonomous vehicles, AI is at the core of self-driving cars, enabling them to navigate through complex environments, make real-time decisions, and improve safety on the roads. Another significant application is in retail, where AI is used to enhance customer experiences, provide personalized recommendations, and optimize supply chains. Even in finance, AI is being used to predict risks, detect fraud, and automate trading, making it a critical part of modern financial systems. As AI continues to evolve, breakthroughs are occurring at a rapid pace. From natural language processing, which allows machines to understand and generate human language, to AI-driven innovations in robotics and smart devices, the future of AI seems limitless. And that brings us to the present. AI is no longer an experimental technology confined to research labs. It is now embedded in industries around the world, creating new opportunities and transforming the way we work, live, and interact with technology. What started as a theoretical concept has grown into one of the most powerful technologies of our time. In this module, we explored the evolution of AI from its early symbolic systems and expert systems to modern machine learning and deep learning models. In the next module, we will dive into the tools and libraries that make it possible to build AI models, including TensorFlow and Keras, two essential frameworks for any AI practitioner.